Let's talk about Lesson 8, Activity 3, Question 3. If triangle ABC is reflected on the y-axis to obtain DEF, what is true about triangle ABC and triangle DEF? And how do we know? Now, again, this is a question out of your workbook, and something I didn't have space to include here is that you're instructed to first answer the first question, which is what is true about triangle ABC and DEF, and then to answer, well, how do you know? So you're choosing a statement and then picking a reason to support that statement. So let's take a look at the triangles. So ABC was reflected on the y-axis, so meaning we started with this triangle ABC, the y-axis became our axis of symmetry, and this was reflected over to create triangle DEF. And I want to know what is true about these two triangles. What's true about the relationship between them? So let's inspect our answer choices here. I've got triangle ABC is congruent to triangle DEF. A reflection is an isometry, a reflection is not an isometry, and so on. So what I want to pick out first of all is notice that some of these answer choices correspond to the first question, which was what is true about triangles ABC and DEF, and then some of these answer choices correspond to the second question. So let's sort those out. So to me it looks like I need to sort my claims and my reasons. It looks like this would be my claim, so maybe I would claim that it's true that the triangles are congruent. Maybe I would claim that it's true that the triangles are not congruent, or maybe I would claim that there's not enough information to determine whether they're congruent or not. And then the other answer options would correspond to the second question. So how do you know? Well, the other answer options are all reasons. So a reflection is an isometry, a reflection is not. In order to determine congruency, each pair of corresponding sides and angles must be shown to be congruent or not. So I need to pick my statement or my claim and then pick why I know. So starting with our statements in yellow then. Okay, so based on this picture and based on the information about it being a reflection, are these congruent? Are they not congruent? Or is there not enough information? Well, hopefully you reviewed my video from the last lesson, and if you did, then you'll know that these are congruent. These two triangles are congruent. There is enough information to determine this, and again, they are congruent, so I'm able to eliminate the other two answer choices. Now I need to support my reason, and my reason is either that or because a reflection is an isometry, or because it is not, or in order to determine if triangles are congruent or not congruent, each pair of corresponding sides and angles must be shown to be congruent or not. So, which one of these supports my statement? Well, the last one clearly doesn't, right? So it talks about, it's a true statement that in order to determine if triangles are congruent or not, we have to show corresponding sides and angles are congruent or not. That's a true statement, but it doesn't apply here because that's not what we're doing in this example. So again, true statement, but not relevant here. So that's not the reason why I'm able to claim this in this example. Key thing here would be to notice the phrasing, which told me that triangle ABC was reflected to obtain DEF. So my answer has to do with reflections, and it turns out that it's because a reflection is an isometry, meaning that my angle measures and my line segment measures are preserved. So, for example, line segment AC would have equal measure of line segment DF, angle B and angle E would have equal measure, and so on for each corresponding side and each corresponding angle. Now, that is not congruence in itself, but by definition of congruence, if two line segments have equal measure or if two angles have equal measure, then they are congruent. So this is kind of a major, it almost seems like a major jump because there are a bunch of kind of nuances and small pieces that come along with this claim, but it's almost like a really brief type of proof. So yes, they are congruent because a reflection is an isometry, which preserves our angle measures in the reflection and preserves our line segment measures. And if all of those are still preserved and equal to one another, then each of the line segments has a corresponding congruent one. each of the angles in the ABC triangle has a corresponding congruent angle in triangle DEF. And if triangle ABC has all of these congruencies with triangle DEF that I've already outlined, then the two triangles are congruent.